Hello, bonjour, it's Laura here. In this video, we're actually going to solve a stoichiometry problem. So in the last video, we set out the plan for it. This time we're actually going to do it. All right, so I've got a problem written here. So it says determine the mass of ammonia that can be formed from 23 grams of nitrogen or nitrogen gas. So first thing we always do when we're solving these chemistry stoichiometry problems is look at what is given and needed in the question. And then after that, I always make a plan of how I'm going to solve the problem. So the information that's given is that we've got 23 grams of the nitrogen gas. So 23 grams. And remember, it's always important to write the element or the compound with the grams. And then what we need is the mass or the grams of the ammonia. So grams of the NH3. Okay, and notice the question also gives us a balanced chemical equation. So that's wonderful. Also remember, if this is not balanced, we must balance it. But luckily, this is balanced, so we don't have as much work that we have to do. So let's make a plan. So remember, we talked about this before, that we can't convert from grams directly of one element to grams of the other. We have to connect the information using mole-to-mole ratios that come from the balanced equation. So what we need to do is take the grams and convert it to moles. So then when we've got that mole information, we can actually use the information from the balanced equation. So the first step we're going to do then is take the grams of the nitrogen gas and convert that to moles of nitrogen gas. And how do we do that? Well, of course, we use our molar mass information. And that information we can get directly from using the periodic table. So we just look at how much does 1 mole of nitrogen weigh, or what's the mass of that, and then we multiply it by 2 because there's 2 in that molecule of gas. All right, so once we know the moles of the nitrogen gas, we can figure out the moles of the ammonia. And how do we do that? Well, we use the mole-to-mole ratio from the balanced equation. Okay, so this information, we can get that from the periodic table. This information would get that from the balanced equation. And then once we have the moles of the ammonia, then we can go convert that back to the grams of ammonia, because the question doesn't ask us just for the moles, it asks us for the grams. And to do that conversion, we're going to use the molar mass again. So that's going to be 3 steps. So I'll do this in order: step 1, step 2, and step 3. All right. So that's going to be our plan, and that plan is a standard plan for stoichiometry problems. If we are given grams and we ask for grams, we need to do these 3 steps. You can have questions where you're given, say, the moles, and if you're given moles of something and then you're asked for grams of something, then you just do the second 2 steps of the plan. Okay, and I had that all figured out there. Now, this is an important point as well, and this is a good practice that a lot of students like to do, and that is before we even start the plan. Before the plan, calculate your molar masses of all of the compounds that you're going to need. So we know that we need the information for I'm just going to erase this so we can read it better. We know that we need the molar mass of the nitrogen gas and we know we need it of the ammonia. So what you can do is calculate your molar masses first. So write that up at the top of your page. It's nice because then you can really get into flow almost when you're doing your conversion factors in your big plan, because you've already got all of your other calculations made. So when you do that, actually students get to really like stoichiometry because it's a nice flow. It's almost like doing a little craft or something like that. Okay, so let's start our plan. So the first step is going from grams to moles of that nitrogen gas, and then here is my calculation. So you can see that could be pretty fast, and it's because I've already figured out my molar mass here. So 1 mole of the nitrogen gas weighs 28.02 grams, and so I'm canceling out my grams of the nitrogen gas, and then I'm left with my moles of N2 or nitrogen gas. So that's step 1. Then step 2 is our mole to mole conversion factor. So see how this number here, the 1.35 moles of nitrogen gas that I ended up with, that is now my given in my second conversion factor calculation. So now I've got 1.35 moles of the nitrogen gas. I've got my conversion factor here, my moles of the nitrogen gas cancel out. I'm left with moles of the ammonia, which is what I want. Now, I'm sure you remember this, but just in case, where did I get the information of the 2 moles of the ammonia would be produced from 1 mole of the nitrogen gas? So that is from the balanced equation. Okay. Oh, I'm having pen problems again. So that is from the balanced equation. And then I get 27 or 2.7 moles of ammonium. Okay, so that was step 2, and then we've got one more step, step 3. Now we're going to go from moles to grams, and now this is of the ammonia, not of the nitrogen gas. And remember, we already calculated the molar mass of that ammonia. So notice my answer in step 2 now becomes my given in my step 3. So I start with 2.7 moles of the ammonia, and then I use the conversion factor here that comes from the molar mass. So my moles of the ammonia cancel out, and we know that we've already calculated this, so that's why we get the flow here. 1 mole of the ammonia weighs 17.034 grams. And so then when we do this calculation, we get 45.99 grams of ammonia. So that's the answer. So therefore 23 grams of the nitrogen gas will produce 45.99 grams of the ammonia. Okay, so that's an example of a full stoichiometry problem going from grams to grams. So well done, miigwech.